my talk. I know there are other talks going on at the same time. It's very difficult to choose lots of talks, so thanks for going for the easy one. um, this is a talk called The Sane Way to Build Cloud Infrastructure. Okay, basically, what I want to talk about in this is how we actually build and deploy our systems for the cloud. Anyone use the cloud? Amazon? Azure? Google? Nobody for Google, wow. Wow. So mostly Amazon users. You're mostly sane people. My name's Paul Stack. At Twitter, I'm at Stack72. I work for a company called HashiCorp. HashiCorp. Anyone know HashiCorp? Oh, excellent, excellent. So yeah, I work for HashiCorp and I work on the tool called Terraform. This is not a sales pitch. Okay, I don't care what tool you use a tool. And as we go through, we'll see why tools are better, okay, for what you do. You will see a demo, 100% demo using Terraform, because I build it on a day-to-day basis, and I know it very well. But I'm not here to tell you you must use Terraform. Okay. This talk is not about containers. They are what I believe, what everyone thinks is a silver bullet, and I'm not going to go on a rant about containers. There is a talk about containers happening right now, so go to that one if you want. It's nothing to do with serverless, because that is just platform as a service repackaged. And it's definitely not to do anything about nano, pico, or microservices, okay? Because they're like just small words put on the end of service. And it doesn't include any other real hype. We're going to talk very briefly about the history of infrastructure management. Okay, what are the split ops people in the room? Oh, he's afraid to put his hand up. It's okay. I'm an ops person as well. We can be proud of what we do now. Hopefully, mostly developers. Yeah, and any QAs? Oh, one QA. Nice. Welcome. Nice. So in the beginning, okay, we used to do what was called Snowflake servers. Okay. Now, Snowflake servers is a term coined in 2012 by Martin Fowler. Everyone knows in programming knows who Martin Fowler is. And what he said is it's the idea that it's physical infrastructure, usually physical infrastructure, with a long life, and it's manually edited by a lot of people. So someone RDPing into the Windows console, or someone SSHing in and running an apt-get install, or whatever package manager there is in Windows these days. And it's very much not a controlled manner and a controlled way of doing things. And he used to say that if you have 10 servers that are managed in this way, not all 10 of them are guaranteed to be the same. Okay, they're very individually unique, thus the term Snowflake. Now, if you're still doing this in your company, don't be ashamed, because I see companies doing this every day. I really do. And I see people trying to adopt better ways of doing it. So the realization that knowing that you do this and that you should possibly change is a better thing than just actually being annoyed about it. Okay, so don't worry if you're still doing this. There is hope, I can guarantee. Physical servers like this in Snowflake Industries are usually managed by a runbook. I used to work for an organization that the runbook was 56 pages of a Word document. Okay, and I was working there in 2008. Yeah, 2008. And there were still pictures and screenshots in the runbook of Windows 2003. So this denotes perfectly why runbooks are very difficult, because they're created once and we don't really update them. Like, it would have been very easy for someone to actually take new screenshots when they were building something and update it. I didn't even do that, because I didn't even have Word on my machine. I had to get someone to export it to a PDF and actually I could read it that way. But runbooks are a bane of our industry. They really are. Does anyone still use runbooks? Wikis? Wikis are a similar thing, right? Wikis sometimes don't get updated as well, and sometimes you look at a page and you're like, oh, what? That's not right. So the same thing happens. These documents actually have to grow with our code and with our organization, and we must actually remember to make them first-class citizens of what we do. Think of a handcrafted server as a pet. Okay, it has a name. usually something meaningful like database production '01, okay, or US data center '02. And when it gets damaged, we get upset. We don't like it. We get a bit down if our server goes down in the middle of the night, okay? If one of our pets gets sick, what do? We take it to a vet. Okay, we get the pet taken care of. So the same thing happens with a handcrafted server. If someone has put a lot of time and effort into manually maintaining that over the years, then they're going to be very attached to it. Then the realization was that maybe we should use another tool to do this. Okay, configuration management tools, Puppet, Chef, Ansible, Salt, CF Engine. There are lots and lots and lots of configuration management tools. In fact, it's a very growing industry in the DevOps world. Very, very growing. And what the tools would allow you to do would be to describe the state of what a server or infrastructure would look like. So you would say, when the server comes up, the server should have these 4 users on it. The user should have these permissions on it. They should also have these 5 packages installed on it. And that's what configuration management would do. And you would be happy that every time you run it, it would bring it to that known point. And thus the term Phoenix servers was created. So Phoenix servers was another term coined in 2012. Martin Fowler worked for ThoughtWorks. This also came out of ThoughtWorks. It was by a lady called Cornelia Siestema. And it says that you can happily destroy or change your infrastructure and bring it back, and it will rise like a phoenix from the flames. But, with great power comes great responsibility. This was a Stack Exchange question opened a few months ago. And basically somebody was using Ansible, and somebody actually ran the command rm-rf -- no previous across all of their infrastructure using Ansible. Now, Ansible will allow you to recursively talk to all the servers in your cluster. And the guy was basically, I've lost all my customer data, what can I do? At that point, you've got a problem. So maybe if you're using a configuration management tool, be careful. A note on this, it's actually turned out to be a troll. Okay, this didn't happen as far as we can tell, but it was a very hot topic on Hacker News and Stack Exchange and all over Twitter. So it's funny. The lesson to learn here is long-running servers suck. Because what happens is your development environment is pretty much guaranteed to be different to your production infrastructure. And when you take that little binary that you create and you put it into production, all hell breaks loose. And you're like, oh, I don't know, it worked fine on my machine. It must be the ops, it must be the environment problem. How many people have blamed the environment for a deployment? I have when I work in operations. Okay, and this is what happens. It becomes someone else's problem then. The cloud has since sort of taken a lot of prevalence. Okay, it's very popular. Anyone want to take a guess at when the first cloud infrastructure was released? 2004? Anything different from 2004? 2002? You're getting closer? 1999 is exactly right. Okay, so the cloud has been around for 17 years now, and the first launch was Salesforce.com. They actually launched their platform as a service, or their software as a service back then in 1999. Excuse me. Amazon didn't launch their first thing in the cloud world until 2002. Azure decided that maybe the cloud would catch on, and 11 years later released their first thing. Sorry, anybody that works for Microsoft. But it was the new way of doing things. And because it was the new way of doing things, we had to think of an alternative way of working. So let me put that in an actual example. When you bring up an instance in Amazon, it doesn't have a very pretty name. It has something that looks like I dash and then a list of integers and letters. So Having a handcrafted way of doing that is not very nice, because you would have to go to the console, you would have to search for the name, you'd have to grab the IP that way, or you would have to run a bind server and put your own DNS entries across the top of it. You can also not guarantee that an instance launched on Amazon today will be there tomorrow. Because what happens under the hood is they have their own physical infrastructure. You're launching on the cloud. The cloud is someone else's data center. And they have to patch their data center. They have software updates happening. And they roll your instances from server to server to server to server. And when Venkat spoke in the keynote this morning about not having state in your systems, or trying to reduce the level of state in your systems, the same thing we can try for operations as well. Because if your server is in the cloud and it has a lot of state and it dies, then you got some problems, because when it comes back up, you're not going to have that state anymore. So you have to give it some real thought. So in 2013, Chad Fowler, who's very well known in the Ruby community, actually wrote a blog post called Trash Your Servers and Burn Your Code, Immutable Infrastructure and Disposable Components. And what he introduced was the idea of immutable infrastructure. Immutable infrastructure basically means you build it once. If you have to change it, you throw it away and start again. So it's bringing the thoughts of immutability from the functional programming world into infrastructure. But of course, those lovely functional programmers pointed out the flaw in our ways last year. And they said, well, it's not really immutable, because the state of the server always changes. You have logs being written. You have processes starting and running. You have users that log in. And they were right. So the better way of describing it is disposable infrastructure. It's been created for a purpose, and then you can throw it away. I apologize to the vegetarians in the room, but think of it in terms of cattle. Okay, they've been bred for a purpose. Usually, in the end up, it goes for something like meat. Okay, cattle don't have a name. Farmers don't have 500 cattle on a farm and go, this is Henry, this is John, this is Victor. Because they can't tell the difference. They're all very similar, and they're all created in the same way, but they can be guaranteed to bred to do a job. And once they've done that job, they get a new one. So we're going to go and have a look at demo. I'm going to use two tools. As I said, these are HashiCorp tools. Use whatever tools you want, and I'll show you some of the other tools at the end, okay, the names of some. But we're going to go and build something in AWS. Okay, what we're going to build is this. This is a VPC, your own virtual cloud. Okay, we are going to take a very small segment of the Amazon data center in Ireland, EU West 1, excuse me. And we're going to put some public subnets, and we're going to put some private subnets. And we're going to put an application in the private subnets. We're going to put a load balancer in the public subnets. We're also going to put a NAT server so that we can SSH in or VPN in the public subnets. And then we're going to hope that a demo works. That's the theory. Let's give it a shot. Okay, so everything in Terraform is declarative. Okay, we use our own configuration language, which is a DSL called HashiCorp Configuration Language, HCL for short. And you write your servers and your infrastructure in the same way as you would write code. So everything starts with a provider. Terraform has many providers. Okay, it's Google, Amazon, AWS, DN Simple, DNS Made Easy, MySQL, InfluxDB. It has all sorts of providers that do lots of different things. We're going to start with just the AWS provider and nothing else. Okay, we're going to tell it a region, and straight away I want to introduce a best practice here. Okay, there is no hard-coded information here. For me, I'm going to run this in EU West 1. But if I wanted to run it in another place, so if I wanted to change it to US West 2, I would just have to change the variable name. Okay, The variables are here. And all I would have to say is US West 2, etc. Okay, one place to change my variables. Let's not save that because that demo will go wrong. Now what we're going to do is we're going to introduce a key pair. We're going to create a key pair called XP days. And I'm just going to show you that it doesn't exist. Key pairs, none. So a key pair is an SSH key. You take a copy of the public key, you upload that public key to Amazon, and that public key gets put onto the machines that you want to SSH into. Excellent. And if I run the command terraform plan, excuse me, make SSH key, shows it doesn't even exist on my machine yet. Let's make it. Excellent. Terraform plan. What terraform plan does is it takes a copy of what our infrastructure should be, and I'll explain how it does that in a second, and it compares it against the cloud environment in which we want to interact with. So in this case, it's basically saying, tell me what my infrastructure should look like, and compare that with Amazon. And what you can see is it's going to add one. It's going to add one resource. It always gives you a plan and an output of what it's going to do. Okay. Now, how does it build what the infrastructure should look like? Terraform is based on graph theory. So it uses a directed acyclic graph, excuse me, and it understands the relationships between what you want to build. And it forms the graph and the order in which it does it, and then it walks the tree in order to do it. It's very sophisticated under the hood, but the users don't really need to care. What you can guarantee by doing is because of the relationships in the code, you can say, when I bring up a VPC, then I need to bring the VPC up first before I put subnets in place. I need to bring up subnets before I put instances in place, and so on and so forth. So it allows you to build a very complex graph, and we can actually have a look at what it does. So make graph, and if you can see this right here, what it's saying is the provider AWS is dependent before you can actually put a key pair in place. That makes sense, right? Because where are you going to put the key pair unless the provider is declared? Let's close that. And if I terraform apply it, it's going to do exactly the same thing in reverse. It's going to take the structure of what our environment is, and it's going to replay that against what's in production. And I'm really hoping I still have internet. You know what? There we go. It is creating. There we go. It's usually a little bit faster, but the Wi-Fi here is going to be a little slow with lots of people on it because it's open. And it'll give you an output, and it'll say apply complete, resources 1 added, etc., etc. So if we go to AWS and we refresh, we can see that it's there. Now, if somebody goes and deletes it by mistake from the console, lots of people do that. Lots of people go onto the AWS console and the Azure console and click around and do bad things. Let's delete it. And if I say plan again, what's it going to do? Because it knows locally in the state that it should have that key pair. And it says, look, I need to add it again. So it's a declarative way of keeping your environment up and running. So let's apply that. Okay, let's go and do something more interesting. I'm going to introduce a new way of doing it called modules. Okay, think of modules as a third-party API. So you're coding against an API, and you have to pass variables into that API. The way that this tends to happen is ops people would write a module for Terraform that is a VPC. So they would take care of things like the creation of elastic IPs, the creation of NAT gateways, the creation of subnets and route tables and associations. And all as a developer you would need to do would be to pass some variables in. We can make this even more simple, but I just wanted to show you that you can pass variables in and change the variables as you go. It's going to create a VPC called XP days. It's going to create 6 subnets. It's going to create many route table associations, etc. It actually will create 27 resources in total. And if I terraform planet, So you must always run the command terraform get if you're using a module, because you need to go and get the module source. It doesn't need to be on your local machine. They can be stored as individual repositories in Git, and it will go and check them out. So terraform get, and in this case what it does is it just creates a symlink because it's a local copy. And if we run the command terraform plan, I can't type, I haven't had enough coffee. I'm usually at least 5 cups of coffee by now. There we go. 27 to add, 0 to change, 0 to destroy. Terraform apply. And if we swap across to the VPC, we'll see that there's nothing there right now. And it started creating some stuff, which is really good news. And if I refresh, I should have a new VPC called XP Days, which is right here. I should have some subnets. There's the first 3, the first 4. They're all there already. So they were all very quick in running. And it's creating the route tables and so on and so forth. It gives you an output of what it's doing. It always gives you an output of what it's doing so far. And it'll take I think it takes like 2 minutes for the NAT gateways to come up. It's an Amazon thing, it's not a Terraform thing. But Terraform will wait until they come up, and then it'll report that it was a healthy status and continue on to the next operation. Right. If it ever finishes. NAT gateways. We should see them being pending. Yeah, they're in status pending right now. Anybody got any questions so far? Anyone care? You care? Oh, awesome. 2. I'm happy with 2. I have 2 I can deal with. So, does anybody use this tool already? A couple of people. Now, sometimes it can be an interesting tool to get started with. And I know it's very challenging in order to get up and running with it, but we're continually making the tool better because feedback from users are very key. But also, because we dogfood our own tools, we actually use our own tools to build our own infrastructure, it makes us aware of the problems in our own tools. So giving this demo, I've given this like 20 times, given this demo, we find bugs, and we can go and fix the bugs straight after the talk, and then the next version it's fixed. So it's really useful to be able to understand our own tool. There's the first one is available. You can see it's now associated with an elastic IP. Second one's available. Last one's just going to be a bit pesky. Excellent. All 3 are available, and this should now come out and say creation complete. There you go. 27 resources added, 0 changed, 0 destroyed. So we actually have now built the VPC with the public subnets, the private subnets, and so on and so forth. This code is all available on GitHub, by the way. I have a repository called XP Days UA 2016. You can go and download it all and play with it. So we're going to take the next part, which is a VPN. If you are going to take this code, please do not use this specific piece of the infrastructure in production. This uses an OpenVPN server with an elastic IP. It is not HTTPS ready. It does not have a certificate. And just be very wary that this is for a specific demo. Okay? You could take this code and you can enhance it and put a certificate on it and actually make it more robust. But this exact part right here, probably stay away from in production right now. This is just as an example. Now, what this is going to do, so modules, and we're going to go in and look at VPN. As you can see, there's a very small API, the variables that we need to pass in. So VPC ID, the public subnets, which is a list, key name, an AMI, and a tag name. It's going to create a security group. Everyone knows what one of those are in Amazon, if you're there. And it has some ingress blocks and egress blocks. These are well documented for OpenVPN. Okay, you go on the OpenVPN website or the appliance site, and it will show you and tell you the list of them. And then lastly, it's going to create an instance. So it's just going to run the equivalent of the command AWS EC2 run-instances, and then the parameters that it would pass in. As you can see, the only thing right now that is hard-coded is that it's a T2 micro. T2 micro is very sufficient to run an OpenVPN server. If you change that and you take this example and mess around with it, it will cost you money to run. So be very wary of that. We associate the VPC with the instance, and we pass in the key name, and we have a user data file. User data file sets a username and password. Again, don't do this ever, ever. And the password is very secure. Really secure. So this is why I'm saying don't do it, because you never want to store passwords in plain text like that, ever. Ever. If ever you take anything from this talk, it's don't store passwords in plain text. And lastly, Terraform has the idea of an output. So it has a variable for input, but it also has a variable for output, okay, or an output syntax, it's called, because we want information to come back to the user. We want the user to see IPs and DNS names and so on and so forth. So we output the VPN ID or IP. So that's going to get the public instance ID, and that gets pushed back to the environment. And you can use interpolation syntax in order to actually give the user meaningful names. So, for example, when the IP comes out, in order to see it, I would need to go to this web address. And all I do is just use interpolation in order to say it's HTTPS/the IP. And that'll come out to the user. So, Terraform get. Excellent. So Terraform plan, all it's going to do right now is add two more things, a security group and an instance. It always refreshes the state. Unless you tell it not to, it always refreshes against local so that it understands that everything is working as expected. Ignore all the numbers, they're just boring. There we go. Plan, 2 to add, 0 to change, 0 to destroy. Lovely. So, Terraform apply. Now, in the background, CD conferences, XP days, Terraform, my environment. Export. So I'm going to run the command make graph. We saw the very simple graph before, okay, which was just a provider which depends on a key name. If I make the graph, so the reason we pipe it through dot, okay, if you run the command terraform graph, by default, it gives you a list of that. That is not readable in any way, shape, or form. So we take that output and we pipe it through dot, which is a package for OmniGraffle, and it produces the PDF for us. And if I open graph.png, we can now see that we have a much more interesting infrastructure. So let me try and explain what this does. So we have the key pair. That has no real dependency below it, so it can create that at the first level. Okay. Then because we're inside a new module, it understands that it has to create the VPC before it can create the internet gateway, the private subnet, the public subnet, and the security groups. Okay, because they're all related to each other. Then after it's created that, it knows that it can create the route table public, the NAT gateways, and the route table associations, because it understands that the level below it has been created. And then lastly, it understands that it can create the instance, and the public route table associations and the NAT routes. So Terraform has built this for me. I haven't had to go and tell it, build the VPN first, build the subnets next. It understands the order in which it needs to build things because it's got that API knowledge and the SDK knowledge embedded within it. So the question is it because it understands what the objects are? Yes, right? Because if we show you again, if I go to VPN, VPN takes a VPC ID. It also takes a list of public subnets. So what you're doing, and you don't realize that you're doing it, you're building the graph. Because you're actually saying, I can't build this instance until there is a VPC ID. And I can't build the subnets until there is a VPC ID. And that actually is what helps you build the graph. So Terraform has all of that knowledge embedded in it in order to do that in the most effective way. And if you can see, the green is horrible. It looks brilliant on my screen. You can see that it's got an SSH command if you really want to SSH into your node, but it's also got an IP address. And I'm going to take this IP address, and I'm going to go to the browser, and it's going to say your connection is not private. It definitely is not private. Let's proceed, and we're going to have our login window, hopefully. It's thinking about it. The Wi-Fi has dropped to 1 kilobyte a second. Oh, there we go. Excellent. And we're going to log in with the super secret password. It doesn't even have to be stored in one password. And it's going to give us a profile that we can download and use in a VPN software. Okay, so we're going to download one. And I use a piece of VPN software called Viscosity, which is very simple, very easy. And we'll come back and we'll connect to that in a second. So where do we go from here? Now we get to the good stuff. Anyone use AMIs? Excellent, excellent. So an AMI is a pre-packaged instance in the way that you would describe it. Oh wow, 15 minutes already. We should be good. So you would actually define the characteristics of what your machine image and what your instance needs to look like. Okay, you would then create that. Amazon will create a snapshot of it, or it's got the metadata around it. And when you launch an instance, you can launch it based off your AMI. This is, up until very recently, I don't know if it's still the case because of the rise of Docker. This is very similar. Well, this is actually how Netflix deploy their software. Everything gets packaged as an AMI. Everything is pre-configured. So when they create a new build, the piece of software is baked into an AMI, and then the time taken to launch the instance is just the boot time, because all the work has already been done to put the software into the instance. This is going much more towards the immutability side of it, because once it's been built, you don't have to touch it. You just launch the instance, and everything is already on the instance. So it's very fast to boot. And we would use a tool called Packer for this. You would create, this is disgusting, this is JSON. You'll have to forgive it. We're going to create some things here. Oh, that's the wrong one. We're going to use something called console. Okay, console is like a library we use internally for service discovery. This is not about console itself. This is just about pre-packaging an AMI. So Packer has three components to it. It has builders, it has provisioners, and it has post-processors. Those are really important, and we'll talk about why. Each of them are an array, okay, an array of builders, an array of provisioners, an array of post-processors. So we're going to use the Amazon EBS builder. Okay, so it knows that it actually launches an instance in Amazon in a specific region using a specific base AMI. So like Ubuntu Trusty 1404, that is like from Canonical. It's available to use. It's got nothing on it. It's like the bog standard. We want to launch it on a T2 micro. You want to make this as cheap as possible. We want to give it a description. So console server image. We want to give it an AMI name when it comes out, when it's been finished. And it has the console and then the timestamp. And then we want to run some provisioners. In this case, I'm installing the AWS AMI tools, EC2 tools. I'm running a yum update. I'm going off to Package Cloud and I'm downloading a package and installing it. Okay. Now, an actual example. Anyone know TeamCity? Okay, cool. So, well, yeah, package TeamCity. CD. CD Packer, cat, TeamCity server.json. So here are the multiple outputs, okay? So this is like our TeamCity server. And what we do is we obviously have a provisioner for Docker. We have a provisioner that goes off and installs some plugins in our engineering services CA. We can upload files, we can run shell commands. So you can make it as sophisticated an image as you need it to be, and you just declare it in provisioners, and it will go and run them one at a time down the list. And then lastly, you would have post-processors. You don't need a post-processor in this case because we're using Amazon EBS, and it knows that it's building an instance, it's building an AMI, and that is the post-processor. That knowledge is built in. But the interesting thing about this is you could have an image, you're building like a Windows image or a Linux image from source for your own local data center, and you could actually have a post-processor that outputs it to DigitalOcean, one that outputs it to Google, one that outputs it to VMware, and one that outputs it to like a local Docker file. So exactly the same configuration that you would put on your servers can be used to build local images. And what I tend to do, people are like, oh, you know, what benefit does this give me? Right now, I'm just going to, by the way, it takes a couple of minutes for this to run. I ran Packer this morning just before I got into the talk, just so because it takes like 10 minutes to build the image, and I'll show you why. And you can see the full output of Packer. And I'm just going to launch the, while I continue talking, I'm just going to launch the actual cluster. Okay, cool. I can just go back and talk now. So you can actually build in server spec tests. Because you have done something to an AMI or an instance, you want to maybe check that the instance is exactly how you described it. So there is a package on the internet that's just an open source package called server spec, and you can write tests that look like this. When I bring up the instance, Nginx should be installed, it should be enabled, and it should be running. NTP should be installed, should be enabled, should be running. You can do the same thing for users. User X should be on there. This group should be applied. This permission level should be applied to this folder. You can actually test how your server looks before you launch an instance based on it. So you can package your infrastructure, package your product into the infrastructure, test that the infrastructure is exactly how you made it look, and then launch an instance based off of it. And that's what we're doing right here. I'm using a data source. So right now, I'm going off to Amazon, reading the AMI ID of the latest console image. You can put as many filters in there as you want, okay? Times, versions, whatever sophistication you want to get the correct AMI ID for you. Because what I don't want to do is every time somebody has updated console, the package or the AMI, I don't want to have to go back to Terraform, edit the file, and change the AMI ID. I want to go off and get the latest so that I know that when I build my auto-scaling group and my launch configuration, very AWS specific terms, that it's using the latest and thus the tested way of doing it. So what are we doing in here? Again, we have an API. We're building some security groups. We have lots of security groups and ingress and egress rules. So we're going to skip down through them. We're building an IAM rule. We want our server to have a specific IAM, a specific identity, a specific like user associated with it, so that no one else can do anything that they shouldn't need to. We're creating a launch configuration. Nothing is hard-coded in here. Everything is being passed in as variables. We're creating an ELB, which listens on port 8500. We're creating a health check so that we understand when the instances that go in the load balancer are healthy. And when they're healthy, they'll appear actually in the end-user load balancer. We're creating an auto-scaling group. In this case, we're actually creating an auto-scaling group of size 3. If you change that to 5, it'll create 5 instances of the server. So, and Amazon guarantees that when you specify an auto-scaling group, it will keep that number of instances running. So if one of them dies, Amazon will understand that it has to spin up another one. And lastly, we want to output the ELB address because we want users to be able to see this on the end. Excellent. So the reason I created a VPN is this is a service discovery cluster. We don't really want to expose this to the internet. This is something very internal to our infrastructure and our organization. So I want this to be behind our VPN. And if I take it, it can't connect. Where is my viscosity? This is because, one second, I've just connected to the VPN. It was in my toolbar in the top right, but everything had shifted it over. So, open VPN, super secret password, and it'll pop up in a second and tell me I'm connected. This is cancel the request. Hopefully it'll pop up very shortly. And if we go back to Amazon while we're there, we can actually see that we have some running instances. I have very short amount of time left. There we go. We have a UI. Okay, we've connected to the VPN. We can now see the UI, and we can see that there are 3 nodes inside the UI. These nodes relate to the IP addresses of these machines. So let's just destroy one. This is immutable infrastructure. Because what I'm doing right now is I'm destroying a node. It's shutting down. In a second, console is going to realize that it's left the cluster. Oh, there you go. It's already failing. And in the background, Amazon is going to go, oh, wait. There should be 3 instances of this running. Let's launch another one in its place. It takes like 60 seconds for that to happen. That's a configurable value in Amazon. But it has to pass, it has to fail the auto-scaling group's health check. You can see that the instance is currently unhealthy right here, and it will launch another one in its place. Now we'll come back, we'll let that happen in the background, and we'll just finish the last couple of slides, and then we'll come back and see that it's replaced it in the cluster. That's fine. So we've built this infrastructure and we've put servers in place and we've put the route table associations in place in order to let our infrastructure be there, be created. I told you, I don't care what tool you use for this. I really genuinely don't. This is not a case of telling you Terraform is the best tool. It is the best, in my opinion, but that's purely my opinion. Okay? There are other tools, CloudFormation, which is by Amazon. They do this, and they do this really well because it's built by Amazon for Amazon. Azure Resource Manager, which is this horrible blob of JSON, when I Googled Azure Resource Manager, that is what you would have to specify for to do the same thing in Azure. There are other tools like Sparkle Formation. There are Troposphere. There are lots and lots of different tools that will allow you to do this. And people ask me, why did I get involved with Terraform? So Terraform is cloud agnostic, completely cloud agnostic. And in the repo, there's examples for Azure as well. Terraform will talk to many providers, many providers, and allow you to, like, say, bring up the instance. And when the instance is up and it's been provisioned as a MySQL server, then Terraform will connect to the MySQL server and say, access these 3 users on the database. Or put this extension, Postgres extension on the database. Whatever you want to do, it will do it. It's very extendable because all it does is it just uses internal APIs of the cloud vendors. Mary Poppendieck actually said, she asked the question in Agile, she said, how long would it take your organization to deploy a change that involved a single line of code? And can you do it on a reliable, repeatable basis? We often measure ourselves in software, in the actual development side of it, based on something like this. This is where we would say, well, when I made a change, because of our continuous delivery pipeline, I can push that to production in 15 minutes or 20 minutes. Okay? But we've never really, as organizations, asked ourselves that question on behalf of our infrastructure. In your current environment right now, how many people can actually say that their infrastructure can be changed at will? It's very few of us. There are always people in the room that says, yes, we can. But there are very, very few of us who can do it because we don't really have the confidence of doing it in a reliable, repeatable manner. Using a tool like this will allow you to be more reliable and repeatable. We've created a disposable environment. I'm going to run the command at the end, Terraform destroy, and it's going to take the whole environment back down. For the QA in the room, how nice would it be if, when you're about to test your software, that you could bring up an exact production replica, test and go to the UI, that everything's there, and then destroy it at the end. This is what we want. It's one of the most frustrating things for QAs, that the test environment doesn't replicate production. But also, this allows us as development managers and engineering managers to cut the costs on our environments. Long-running QA servers are only probably used between 9 and 6 every day. Wouldn't it be great if we could just spin it down overnight and save the cost? There's no need for it to be running. What about disaster recovery? Somebody asked me before, they were like, oh, have you got a disaster recovery document? I was doing some consultancy, and I printed them the Terraform plan. I was like, there's your disaster recovery. They were like, what do you mean? And I went, if there's a disaster, run Terraform again, and it will apply exactly the same environment. And they were like, really? Wow. What about if there's like one of the data centers in Amazon blows up? And I went, well, you'll have bigger problems, but just change this variable from EU West 1 to US West 2 and run Terraform apply, and it'll bring it all back up. So I actually measured this. I worked in a startup. The startup has since gone bust, but not because of these experiments that I was running. I actually measured that we simulated when an entire outage happened in our infrastructure. And I could fail over to another Amazon region in 6 minutes. 6 minutes. And the reason it took 6 minutes was because Amazon RDS, which is their database server, took 6 minutes to provision. Otherwise, it was a 30-second Terraform run, and the whole system was back up and running. That's the type of disaster recovery that I want. Netflix Simian Army, okay? This way of doing it is based on what they do. There are many ways and tests that servers can go down and they can come back up and everything is created as it was. But you work in this immutable infrastructure way, and you'll very much be able to have confidence that if a server drops or someone breaks something, that you can just destroy it and it'll bring it back up. It's really important. Let's just go back to and see if this server has come back in the loop. It's thinking about it. Anybody any questions while I'm showing this? Question? If I refresh this page, by the way, while he's waiting on the mic, you'll see a fourth server is in here now. Yay! And we're back to a healthy cluster. So we've destroyed a server. Amazon has brought that server back up. The cluster is back and it's stable again. Great. And then lastly, I'm going to run the command Terraform destroy. And it will ask me, do you want to destroy your environment, your infrastructure? Yeah. And it'll happen in the background. Question, sorry.
So I have a question related to Terraform. Currently, Terraform supports a plugin system, but it's quite hard to use them because there is no central plugin manager. Like a few months ago, I created an issue on GitHub, but seems like it's not on the roadmap. What do you think about it?
Interesting question. So the question is, why does Terraform not support a plugin provider?
Yeah, currently all providers are built into Terraform. And if you want to use additional one, you need to compile it or to contribute to the central repository. It's not very...
Okay, so it's a good question. The answer is, right now we support 37 providers. We have pull requests open for another 12, and we have issues for another 14 based off of that. We have so many things that we're trying to get through. We're just yesterday, I believe, we launched 0.8 beta. okay, which is new changes to the graph and stuff like that. We're trying to get the internals correct first, and then we're going to look at, you know, the next level of what we require to do it. So if you can, ping me that issue about the provider, okay, and I'll bring it to our next team meeting and see if it's back on the roadmap again. Any other questions? This man right here, at the front. It's still destroying. It's taking the entire environment down right now. It's awesome.
What do you use for deploy? Do you use Terraform for deploy your application?
Oh, interesting question. What do we use for deploy? Yes, Terraform is deploying all of our infrastructure internally. Okay, so we use a blue-green deploy mechanism at HashiCorp, where we have 2 auto-scaling groups, one blue, one green, and the Terraform applies will do those. It will run and get the new AMI. It will deploy the blue cluster, scale down the green cluster. When everything is working and is available in the load balancer, we know that we've actually failed across to the new auto-scaling group. So Terraform does our deploys for us. Yeah. One last question. This lady right here. You can tweet me any other questions. Okay. Don't mail me. I'm really bad on email. I'm like 1 minute over. If you want to shout, you can shout. Interesting. So the question is, do we change the environment every time? Do we create a new cluster? No. So what happens in Amazon technology is when you specify a launch configuration, the auto-scaling group is based on the launch configuration. Okay? When you make a change to the AMI, a new launch configuration is created. The next time that an instance is launched from the auto-scaling group, it uses the new configuration. And this is why we have blue-green deploy. If you want, at the end, I can show you how that happens. Okay, I'll show you how that happens in a second. Okay, so all I can do right now is I'm like way over time. Sorry for taking up all your morning. My Twitter details are here. If you need to, tweet me, and I'm happy to take you through some more examples and happy to show you some things. I thank you for your time and enjoy the rest of the day.